Hi, welcome to Geometry Video 2. This is the second video of about 4 or 5 that will be preparing you for Task 1 of the HSC year. We're just running through our geometry facts and figures because there's some geometry proofs that'll be in the next task, and it'll be a good reminder for us. So let's get going. Okay. So let's just check out the end of the last video. We were talking about the exterior angle of lots of shapes, so triangles or quadrilaterals, and in a funny way the exterior angle sum of all those exterior angles on any sort of shape with any number of sides is always 360 degrees. Bit of a strange rule, but I guess the more sides and angles a shape has, the smaller each exterior angle is, and so when you add them up it all just equals 360 every time, which is pretty cool. So that's the end of the last, that was just at the end of the last video, so we're moving on. Okay, we've got to check out our congruency tests. Now we'll compare the congruency tests to the similarity tests, and these will be the basis of any proofs that ask you to show that two shapes are congruent or similar. So we need to remember these things. Let's have a look. Now we've got some similarities and some slight differences between congruency tests and similarity tests. Congruency tests, we're going for the same. The two shapes should have the same size and shape. So it's almost like they're mirror images of each other, and you can just pick one image up and put it straight over the other one and not having any overlapping bits. But with similarity we are going for the same shape, but one shape might be twice as big as the other one or 3 times as big as the other one, but the sides will be in proportion. So if one side is 3 times its smaller matching side, then another side will be 3 times its smaller matching side, if you get my drift. But so that's the main difference between congruence, going for congruency proof, and a similarity proof. So let's have a look. So all 3 sides, if they're matching on the two shapes, then you'd have congruent triangles, for example, if you could show that all 3 sides on one of them match all 3 sides on the other. This one has a little bit of an asterisk to it, this SAS test. So it's 2 sides, and it has to be the included angle. So we have to be talking about 2 of the sides and the angle that's in between. So it might be that one and that one and that one and that one, but the angle has to be in between the 2 sides for that test to be working properly. This one's 2 angles. This next one is 2 angles, and one side has to be matching exactly. And this one is a right angle. The hypotenuse we have to have information on, and one of the other 2 sides has to be matching. So that's a quick run through of congruency tests. Now with similarity, there's an SAS test, but it's not exactly the same. The sides have to be, as I said, in proportion. So they don't have to be exactly the same size as each other, but following the same ratio, I guess. In a similar way, SAS, the sides need to be in proportion, and once again, the angle has to be the one that's in between the 2 sides that we know about. And angle's a funny one, because actually we only need 2 of them for triangles, because if we know that 2 angles are matching, then the third one would be matching as well, because of angle sum of a triangle equaling 180 degrees. So that's a quick run through of congruency tests to remind you. Check it out if you need some more reminders. Okay, there's a ratio of intercepts concept which I don't have time to really go into in great depth, but if you look in your blue book on exercise 4.7, you'll see a lot of examples. Not too tricky a rule, so just remind yourself of that before we head into our task. Ask me if you're not sure. Okay, Pythagoras, just a quick reminder of that. When we're finding the hypotenuse, we will add our Pythagoras type rules. We have a plus in it, and a shorter side we would have a minus in it, just as a basic reminder. And we can also use Pythagoras, don't forget, to test whether a triangle is a right angle or not. So if we've got 3 numbers, maybe a 5, maybe a 12, and maybe a 13, to show that's a right angle triangle, we would have to show that 13 squared equals 12 squared plus 5 squared, 169.